Hello everyone, welcome to Mayor Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is Reorder list. Okay, so you will be given a singly linked list. You have to reorder your list in the following fashion. Let me describe it in my own words. Let's say this is the list given to you. Okay, so this is the list. Okay, and then this is pointing to null. And so what you have to do is you have to return something like this. Okay, you have to return this list. So what we are doing is we are picking one node from the start and one node from the end, and we are joining them. So 1 and 5 will be joined. Then we are moving towards the center in both of the sides. Then we are picking other two nodes and then joining them. Firstly, we will be writing the node on the first half. Okay, if you divide this list into half, and then second half, and other than that we are also joining these two. Okay, so we will keep doing this until we reach the very middle of the linked list. So if you reach here, you will just stop here, and since there was no two nodes, only single node was there, you will add it and simply return this list. Okay, so this is what you are asked to do. And if you take example of a even length list, it is also quite same, like 1 2 3 and 4, and then it's null. Okay, let's say this list is given to you. So what you will do, you will break it into two halves, and first node and the last node 1 and 4, then moving towards center from both end sides, then first node for the first half, and then this node for the second half 3, and joining these two. Okay, and stopping when we are reaching the center, and this is equal to null, and so we have to return this. Okay, so let's observe carefully like how we can achieve this. Okay, what we'll be doing is, in both of the cases, whether it's even length list case or odd length list case, doesn't really matter. We will somehow, in case of even length list case, we will get hold of this node. Okay, and in case of odd length list case, we will get hold of this node. So it is the very middle node, and there is no middle node in case of even length list case, so we will just get hold of one node ahead of mid. Okay, this node. Okay, I hope you are able to understand till here. So once we are having hold of these nodes, we will break the list in halves. So if we break the list in halves, this half will be gone to the second half, and this half will be gone to the first half. Okay, so these two halves will separate, and it will look something like this. Our objective, right now it is not looking like this. Right now it is like this: 3 4 and then 5, and then it's null. Okay, so right now it is looking like this particular one. And here it is also same, 1 2 and then null, and then right now it is 3 4 and null. Before proceeding further, you want to have, you know, a way to move backwards in this second half, because you will be moving towards the center, so it will be a little harder if you are not having links pointing backwards. That's why we will be reversing this second half. uh, Let me write clearly here. So after reversing, this will look something like this. Okay, and this 4 3 will 3 4 will look like 4 3, and then it will be null. Okay, after reversing. So we will be working on these two sets, 1 2 null and 4 3 null. Okay, so we just now have to pick nodes one by one and do this thing. Okay, and you know, and we also have to form this link. Okay, so it is then from here, in both of the cases, it is just a 2-pointer approach. We will be having 2 pointers. Let's call this one as first half head, and this one as second half head. Okay, we will be moving these two till the very end, till you reach null in both of the cases. Okay, and let's say, for example, firstly we get hold of 1 for the first half head, and then for the second half head we get hold of 5, then we join them. Then what we will do, for this second half head we will store its next somewhere safe. Okay, and for first half head also we will store its next somewhere safe, because you know, when you will be changing the next of first half head, this is your first half head as of now, your link to the next node of first half will be gone, so you will store it somewhere safe. You can call this next first half node. Okay, you will store it somewhere. Okay, and for this also you will also store it. You will call this next second half node. Now you may ask that why we are storing the next second half node. It is the link to is still intact, but it will not remain intact when you know, you will be changing link of 5's next to 2. So what you will do, second half head next will be next first half node. Okay, so you will be doing second half head next will be next first half node, so that we are forming this link. Okay, this link. So once you have formed this link, you will be having no longer access to this particular node. That's why we stored it at the first place. Okay, now values of first half head, and let me change color here, and second half head will be changing with the help of these two variables, next first half node and next second half node. Okay, so they will be moving here. Okay, I know it's a little bit messy, but I hope you are getting the idea how we are doing this. Or if you want, we can take it to another slide. It was a bit of mess there, so 543 and then null. Okay, so we are doing these things, get storing this next node somewhere. Okay, let's say we stored this here, and then we stored this one here, and then changing these two links. First of all, we will be changing this, so once next will be 5, then we will be changing this link. 5's next will be this node 2, and then these pointers will move ahead with the help of these two stored variables, obviously, and similarly here also. Okay, and it will keep going on in this fashion. Now there is a little edge case that you have to look for in case of odd length. When you will be at this node, when your second half is at this node 2, it's what will be the next second half node, next first half node? It will be null. And when your second half will be at this particular thing, you will be doing something like this basically. Okay, once you are done with it, you know, you will be breaking this link and you know, trying to add 4 to null, which is by the way wrong, because you know, what is the use of adding 4 to 4 next link to null when it is added you know, correctly to 3? We should be having something like this. Instead of that, by that process you will be having something like this: 1 5 2 and then 4, and then it will be pointing to null because of this second half node. Okay, so in that case, if first half node is null, in that case you will not change the next pointer of second half head. Okay, it is currently second half head. Okay, in that case you will not change, you will keep it same, and you will be getting this result instead of that. Okay, I hope you are able to understand. It will be more clear in the implementation part. Let's see the implementation part. And you know, the reversing thing for the linked list that we are doing, if you are not familiar with how to reverse a linked list, then we have made a video on this, how to reverse a linked list. Link will be provided to you in the I button. Okay, you can definitely check it out and then proceed from there. So let's see the implementation. So this is the implementation. This is the linked list reversal logic. You have to watch the video that I will be providing you link for, if you are not familiar with how to reverse a linked list. And other than that, this is the main logic. If there is a single node only, then you will anyways return, because there is nothing to, you know, reorder. It's a single node, so we are fine. And if that's not the case, we will somehow get hold of these two nodes that we were talking. Let me write more clearly in the next slide. So in case of, let's say we are having our odd length list 1 2 3 4 and 5. In case of odd length list, you want to have, you know, reference or address of this particular node. And in case of even length list, let's say 1 2 3 4, you want to have hold of this particular node. Okay, so when these two when you know, you will be having hold of mid of linked list, basically it is, you can also call this as mid. Actually there was no mid node, so we took the very next node to the mid, and here the mid node was there in case of order length list. Okay, anyways, we want to have get hold of these nodes in these two different cases. So how we can do that? For that, what we are doing is, let's take this as our example, 1 2 3 4. We will be having two pointers. One is fast and another one is slow. Fast will be moving twice as the speed of slow. So fast will be jumping two nodes in one go, and slow will be jumping only one node in one go. Okay, and you will terminate this whole thing as soon as you do not have any other nodes to, you know, visit. So when you will be terminating this whole thing, fast will be at this point, which is null by the way, and second will be at this point. So why is it happening? Why we no second node slow? Why slow is getting eventually at the node that we are desiring, the very mid of linked list? Because you know, fast distance covered by fast, when it will be reaching null, it will be the twice as the distance covered by slow, because fast is moving twice as speed of slow. Okay, so when fast will be at the end of the linked list, where will be your slow? Halfway the distance. What is that? Mid of the linked list. That's why this whole thing is working out. Okay, so this is what we are essentially doing here, starting both fast and head from the very beginning, which is head, fast and slow from the head, and then we are having another variable also that I haven't talked about with you. Okay, so once we are having hold of this particular node, this node, what we will do, we will break this link and separate first half, and by breaking this link I mean that two next will be pointing to null and this will be your first half, and you will be remain with, and the second half will be this. So these two halves will not have any link between them, so we are breaking this link off with the help of this previous slow. So before updating the value of slow, so this whole thing will continue till your fast reaches to the very end of the linked list, and before moving slow ahead, we will be storing one previous value, so that when your slow will be at the mid node, we will be having address of one node previous to mid node, so that we can break this link and make 2's next to point to null. So this is essentially we are doing here, previous slow dot next is equal to null. So when this whole thing fast will be at the very end, this will be your previous slow. Okay, and once you are done with it, you will just have two pointers. Let me take another slide. 1 2 and null, and then you will be reversing the second half, so it will be looking like 4 3 and null. Then having basically two pointers, namely first half node and the first half head and the second half head. Okay, first half head and second half head. Storing their next node somewhere safe with the help of these two, next first half node and next second half node. So next first half node is 2 by the way, and next second half node is 3. So then you will be breaking this link and making it to join to 4. So you will be doing this. After that you will be breaking this link and make 4 to join to 2. Okay, and then you will simply proceed them further with the help of these two variables, because after these two links are broken you will not be having access to these two nodes, so that's why we stored them. Okay, so then yeah, that's pretty simple then. Okay, you just rearranged your linked list, and that is how we will be approaching this whole thing. Okay, and for that odd length case we are taking care of it. If the first half or you can say next first half node is null, then in that case you will do is not equal to null. Basically in that case you will point second half next to next first half node, otherwise you will keep it the same. So yeah, that's pretty much it, and this is how you will be reordering the whole linked list. And as far as time and space complexities are concerned, time complexity wise it will be, let's say, length of the linked list is n number of nodes, then it will be order of n, since we are doing a linear traversal everywhere that we are seeing. Okay, so everywhere we are doing linear traversals, so it's order of n, linear time complexity. And space complexity wise, as you may have also guessed also, space complexity wise we are not using any extra space, just playing with the links, so it is constant. So these are the complexities. Okay, so as you can see, this was linear, this was also linear, and reversal was also linear. Okay, and there was no nesting of loops, that's why linear time complexity. And as you can see, constant extra space. So if you are still having any doubts or any queries in general, then please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.